So I think that'll be something that we'll see in the next 5, 10 years. We'll get some systems that are really performing well on UAVs that can get both topographic and also sub water surface data.
Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest today is Lucas Fraser. He is the program manager for the Unmanned Systems Group at NV5 Geospatial. And today on the podcast, we're going to be talking about LiDAR. And specifically, we're going to be talking about LiDAR from drones. Just a quick personal message from me before we get started today. Sometime in the next few weeks, this podcast is going to round or past the 400,000 download mark, which is a huge milestone for me personally. And I just want to say thanks. Thanks very much to all of you that listen in each week. Thank you very much to the people that reach out to me and share their thoughts, their feedback, their encouragement with regards to the podcast. I can't tell you how much I appreciate it. I understand that there's a lot of competition for your attention. And the fact that you choose to spend an hour, 45 minutes with me each week, it really means a lot to me, and I deeply appreciate it. So thank you very much. Hi, Lucas. Welcome to the podcast. Thanks very much for taking the time to do this interview with me. I really appreciate it. So today on the podcast, we're going to be talking about LiDAR scanning from drones, which is not something we've covered before. So I'm really looking forward to the conversation. Before we get into all that good stuff, would you mind just sort of briefly introducing yourself to the audience, please, and perhaps letting us know how you got involved with geospatial?
Hi, yeah, Daniel. Great to be here. Thanks for having me on. I'm the program manager for the Unmanned Systems Group at NV5 Geospatial, and I actually got involved with geospatial fairly early on. So I did a geodesy and geomatics engineering program at the University of New Brunswick here in my hometown, and I kind of had the goal of becoming a land surveyor, but I think as a lot of the audience will know, it doesn't really end up working out that way. So when I graduated, I just took whatever job I could find, which ended up being at a local aerial mapping company. And I've been processing LiDAR and kind of interacting with LiDAR ever since then. I worked there for about 3 years, and then I moved on to the Unmanned Systems Group here at MB5, where I've been for about 3.5 years now.
Just out of curiosity, before we jump into the basics of LiDAR and sort of move off into the conversation from there, if you had to give some advice to someone who was looking to get into processing LiDAR, what would you tell them? Like, do you need any specific skills or need to understand any specific tools?
If you have some sort of formal training through university or college, that's obviously helpful. But if not, nowadays there's a lot of great resources online and Facebook groups and LinkedIn where people are talking about that stuff. So I would say to start learning about GNSS early on and INUs and kind of how those two interact together, and then about LiDAR technology, and then just start kind of reading articles and magazines. There's LiDAR magazine and LiDAR news, and there's a lot of great stuff out there that people could start reading and learning about if they're interested.
It's interesting. I was so sure that you were going to say you need to understand these 5 programming languages and this one specific tool.
No, I mean I do program in Python. That's kind of a bit more self-taught, though. I would definitely say it's a huge benefit if you understand the programming languages, but it's not a necessity.
Thank you very much for sharing that with us. I appreciate it. It's always really interesting to hear the perspectives of experts that are involved in the industry. Okay, so let's start with LiDAR. I'm sure that the audience has a reasonable understanding what it is and how it works. But if you were going to explain it to someone who had never heard of it before, if you were going to a cocktail party and needed to explain to people what LiDAR was, what would you tell them?
Right. So if I was going to bore a bunch of people at a cocktail party, I would start by telling them that LiDAR is light detecting and ranging. People are more familiar, I think, with sonar and radar, which are similar technologies, but just, LiDAR uses light. And you can imagine it if you're picturing a drone flying through the sky, it's got a scanner on it and it's shooting out eye safe pulses of light. They're traveling down to the ground, penetrating through vegetation and getting down to ground, hopefully, and then coming back up to the scanner. It's really simple when you break it down to the basics. It's just a beam of light. We know the speed of light. We can get the two-way travel time, measure the distance, and then use that to build a three-dimensional point cloud.
So when we get a LiDAR point cloud, are we talking about, is it returning intensity? Is it returning, are we getting color mixed into that? Can we tell anything based on that return about the surface that the return came from?
Yeah, so it's not getting, traditional like RGB visible spectrum color that you're used to seeing. It is, like you said, intensity. And it just has to do with the reflective materials of what we're hitting off of. So if you have a pulse of light that is going off of a reflective vest or something, it's going to be a really strong intensity value compared to, asphalt or something very dark, which will come out very weak. But it does, it does roughly correspond to what you would see with a picture, I guess. When you're looking at LiDAR intensity, for the most part, you can still tell what it is you're looking at.
And earlier you mentioned this eye safe wavelength. So LiDAR is an active sensor, so we're emitting some radiation and we're collecting the signal again and looking at the intensity values from that. Are we using a standard wavelength? So when we talk about LiDAR, is it one wavelength that we're always talking about? Or does this wavelength change depending on some sort of environmental variable?
It is one wavelength, so most scanners are, I think it's around 1064, 1050, or in the 1550 nanometer range. All the companies kind of have different standards, but they're usually using a pretty standard wavelength for topographic mapping. It's just, the best way to get down and see things on the ground. But there is a different wavelength, kind of, it's called a green laser. It's closer to 500 nanometers when you're trying to do bathymetric, so penetrate the water column.
This might sound like a relatively silly question. Can I expect to have those two different wavelengths available on the same scanner?
You can have two separate scanners within the same compartment or in the same body. They can going on at the same time, but they're kind of separate.
But connected to the same IMU and GPS, that kind of thing?
Yeah, exactly. You can have, basically a large number of scanners all connected to the same IMU and GNSS if you want to.
So on a previous episode, we are talking about PDAL or Poodle, the Point Data Abstraction Library, and this is kind of built for point clouds. And I remember my guest Howard Butler. He was saying that a lot of lidar work revolves around reducing the data collected. So you go out and you scan an area, and you end up with an incredible amount of data. Could you sort of walk us through what that reduction process looks like, or and what kind of strategies you might use?
Especially when you're working with drone lidar, it can be an even bigger part of it because in some instances we end up with just way more data than we need. So we'll end up with 300 points in a 1 by 1 meter area, and maybe we need to reduce that down to one, for example. So we have a kind of a lot of internal workflows. I won't go into all of it, but basically a lot of what is generated is topographic mapping. Let's just focus on that for a second. So imagine we're trying to make a ground model for a client. So what we do is we would take the full data set, then we would just classify it the ground, and we have a lot of automated tools to make that work. And then with a little bit of manual bit at the end where somebody looks over it and makes sure all the ground is looking okay. And then we have different algorithms. So you can just isolate, 1 point every square meter, or we have adaptive ones where we thin it based on elevation differences. We can do smoothing. There's a lot of stuff that goes into making these final deliverables. It almost feels silly sometimes, but it's just the unfortunate limitation of a lot of software programs is they can't handle millions of points. So in a lot of cases, you have this really amazing ground model where like I said, you have 100 points in a 1 by 1 meter area. You're picking up just really minute changes, but then it has to be thinned down to go into, I don't know whether it's like ArcGIS or AutoCAD, Civil 3D, the standard programs that are used. But there are other things, you can do break line generation. There are other tools that we do to retain the accuracy of the ground model after it's thinned. But it's funny. It is a lot of work to take something that we already have, with the full density point cloud, and then thin it, kind of dumb it down so that clients and people can interact with it.
So oftentimes in remote sensing Earth observation, you would do some ground truthing, right? So you'd go and look at a satellite image, make your segmentation of that image, and then go out in the real world and perhaps and see, does this actually make sense? Or compare it to a known data set and see, does it make sense? Do you do a similar kind of thing with LiDAR? So let's say you filter out, you have a surface layer, or maybe you've collected all the houses or something and you've pulled that out of your data set. Do you do any kind of ground truthing? And if so, what might that look like?
Yeah, so we always do ground truthing. We generally work with a professional land surveyor, so we have a bunch of them in house, or maybe the client will provide their own. But lidar is interesting. People generally know a bit more about photogrammetry, and it makes sense when you think about you have a picture and you need a certain number of control points to tie it down. But a LiDAR utilizes direct georeferencing. So since we have the GNSS and we have the IMU, all of the points are being positioned off of the coordinate of the base station. So you really only need one control point. But the problem with that is you really have no idea how accurate your data is. So we work with a lot of different ground pros, surveyors, that kind of thing to collect these check shots, these truthing shots, both, on hard, unvegetated surfaces and then, sometimes under vegetation too, depending on requirements to make sure that our ground models are accurate.
Could you just explain to me and the listeners what a check shot is?
That's an important distinction because I know with a lot of the standard programs that you can use to process drone data, I mean, just focusing on imagery for a second, like, Pix4D, Agisoft, you can use points to tie down your data. And for LiDAR, it is just that one point, but you can't use those control points that you've used to tie down your data as check shots in order to do an accuracy calculation. Those check shots have to be independent, they have to be separate than the control, and then you can bring those in. And in the case of LiDAR, it's generally the vertical that we're comparing. So we'll take the offset of all of those check shots to the elevation of the data, and then we'll use that for our accuracy calculation.
So I just want to make sure that I've understood this. So we check shots. We've got some surveyors out there. They survey some points. I'm assuming anyway. And please stop me if I'm on the wrong track. They survey some points, and we put targets, perhaps really reflective targets, on those points there, and then do a lidar scan. We already know where those are in the world, and then we're trying to align a lidar scan to those targets, to those check shots.
That is definitely done. The distinction that needs to be made is that control points are points that you use to reference to tie down your data set. So you'll pick the location of the control point in the data set and compare it to the known value and then bring those together. Those are control points. The check shots, you don't use those to tie down your data. You're just using those as independent checks. It's like it's a point that is not related to the georeferencing at all because that's the problem. Like you don't have many control points throughout your whole data set. So you want to be confident that the areas where you don't have them are good too. So that's where the independent checks come in.
I guess what I'm struggling to understand is, how do I see that in my data set, or how do I make that comparison?
Oh, okay. I understand what you're saying. In the case of horizontal and vertical checks, so it would be a highly reflective target, like you mentioned, something that can be visible in the LiDAR intensity. But often we are only doing vertical check shots. So you would just compare the elevation of the point to the elevation of your LiDAR point cloud after it has been filtered down to ground.
How would you explain to the client the sort of the relative accuracy of the LiDAR data set that you are delivering, in terms of the geographic accuracy and the accuracy within the data set itself? Because I'm assuming anyway, a lot of data sets are made up of multiple campaigns, or multiple flight paths.
Yeah, this is a really important aspect as well. So we break it down into absolute accuracy, relative accuracy, and then density. Those are kind of the three main things we're looking at when we're checking point clouds. And I kind of covered the absolute already. That's the control points, but it can be a problem, the relative, especially for some systems with kind of lower grade IMUs. It can be really difficult to tie the data together if it's not calibrated properly, if you're experiencing IMU drift. So basically, what we do is we take every flight line and we compare it to the flight lines right directly beside it. So we have a difference between every LiDAR flight line. And then we generate a raster with all of those differences so we can see them and then build some statistics off of that raster.
Okay, that makes a lot of sense. So right at the start of the conversation, I mentioned we're talking about lidar being collected from drones. This is going to sound like a really obvious question, but I'd really like to hear your take on it. Why is it important to collect lidar from drones? Like, why not just collect it from a plane? Why not just collect it from the ground? What advantage are we seeing with drones?
Yeah, I mean, to get the basis of it is just because it makes sense financially. It's not just like a CEO pet project or something that we're doing because drones are cool. Like our department, our company has planes, we have helicopters. So we would never use a drone unless it made the most sense and was the best for the client. So the main reasons, I guess, are money, time, safety, and the level of detail that you need. So in a lot of situations, it's just cheaper. It costs money to mobilize a plane or a helicopter. So before you've even collected any data, you already have a large cost that it takes to get that plane or that helicopter to the location. So that's a lot cheaper. For us, we can just put the drone in the back of the car and drive there, or, bring it on the plane, just like a commercial flight, and fly with it to the location. And that's usually a lot cheaper than mobilizing. Safety is an important factor too. So I guess this would be more comparing to traditional methods of collecting data on the ground. But there are some cases where you need a high level of detail. You need to be able to pick up features that you can't see because planes and helicopters are flying too high. And drones are the only way to pick that up, or to have somebody on the ground. And having somebody on the ground in a busy street in the middle of the road, there's safety concerns. And I mean, at the end of the day, it's often slower too if you're covering a large area.
So those are all really great reasons for using drones as a platform to collect LiDAR, and I appreciate you walking us through that, even though I'm sure it was a bit of an obvious question to a lot of the listeners. Can we assume then that because of the cost advantage that you're talking about there, can we assume then that drone LiDAR technology has changed a lot over the last few years and is continuing to evolve? Is that the thing that's driving the price down?
Yeah, it's definitely changed a lot. People have been using LiDAR for a while now. I think maybe 70s, or it's been a number of years they've been using LiDAR, but drone LiDAR technology has really only been past 10 years, and then really exploded in the last 5 or 6 maybe. It's come a long way. At first, it was just the Velodyne pucks, and those are still used today, but at the time that was the only option. They were, originally designed for other purposes, self-driving cars, for example. But now we're seeing a wide range, more competition in the market. There's Velodyne, Regal, which is what we use. We have a Regal scanner, and even DJI has come out with a new LiDAR scanner now. And the Regal scanner that we use actually can be flown on either a helicopter or a drone. So when you fly it on a drone, you're that much lower to the ground, and you're getting that much higher level of detail. That also kind of gives credit to the drone platforms too, being able to carry something that was originally intended for a helicopter.
Could you give us an idea of price?
Sure, there is a big range in price in the market right now, especially with the new DJI systems, and even some companies that have popped up just in the past year are offering integrations for those. So I think that you have to be able to spend at the very least the 20 to 30 thousand dollar range, and that includes the scanner, the IMU, the GNSS system, and the drone itself. So that would be the very bottom that you'd have to spend, and they can go anywhere up to a couple $100,000, which is what we spent on ours.
Oh, wow. So this sounds like it's a sort of modular system. So I was assuming anyway that the IMU and the GPS system were built into the drone itself, and then it was just a matter of sort of plugging on the LiDAR sensor.
Yeah, no, that's a really important distinction because most drones, well, they do have GNSS systems and IMUs on them for their internal navigation, but those aren't good enough to geo-reference our LiDAR. So we actually use a Planx. So we have a Regal scanner and a Planx IMU, and they have a really good, they work together and they have a really good integration, but it's a high grade IMU it's getting around 200 measurements a second, just in order to be able to pick up all of the fine movements of the LiDAR scanner as it's kind of being bucked around by the drone and the different angles it's getting.
Wow, that is a lot of data.
Yeah.
So we've talked about a little bit about what LiDAR is. We've talked about how we're capturing it and some of the sensors involved. And so I guess now would be a really good time in the conversation to talk about what are the use cases for this. So a lot of the listeners will understand that we can build these amazing sort of 3D models based on this kind of data, which is incredible. But what are people using these models or this data for in the real world?
Yeah, so we do a lot of different things with our data. Our two biggest markets that we're in right now would have to be the utility sector and engineering. So for the utility sector, that would be power lines. Utility companies, they're always, replacing poles, building new ones, looking at their existing infrastructure, and we can go in, we collect LiDAR data, and we run a weather station at the same time. And using the LiDAR data and the weather data, they can bring it into a program called PLS CAD and calculate all of the loading, the sag, and the tension. Basically, just how different power lines, and poles are going to react under a variety of weather conditions, and how they're going to react when they add new poles down the line. So it's really interesting, and we also do. fire prevention. So the big problem in California, trees falling, lines hitting power lines, causing fires, mudslides, that kind of thing. So we can go in and collect LiDAR data and analyze it in order to determine which trees are at risk of falling on lines and where areas where vegetation needs to be cleared away. For the engineering space, that's mainly just topographic mapping. So we're able to get really high level of detail with the drones. And it's the LiDAR is not quite as good, but getting close to what would be traditionally collected with mobile LiDAR from a vehicle. So we can use that data to get 3D brake lines on curbs, retaining walls, and inside people's backyards. And the great thing about the drone as compared to mobile is it is getting past fences and in people's backyards, and we're getting a really large swath, and we can use that to do really detailed mapping for road improvements. We did a project for a city here in California where they were trying to analyze their drainage and help that feed into their master drainage plan, see how all the water would flow in the entire city and in areas where it was going to run off. And since we were picking up curbs and all kinds of other 3D features, we were able to really make a model that was good for them to be able to predict all that.
Wow, it sounds amazing. I want to go back to the some of the analysis that you're talking about. There's some of those use cases, and I'm curious. Do you see people are they most interested in the surfaces that you can create using this kind of data, or are they interested in extracting objects out of the data and then using them in their models?
Most of our clients right now are actually interested in the surfaces. So just the data filtered down to its final ground. There's definitely a market for object extraction, and we do some of that. For example, we extract all of the power poles and paint striping, utility boxes, basically everything that you would see. But we actually do a lot of that with our imagery, like our aerial imagery that we collect at the same time as the lidar.
Yeah, I was curious about that. If though, because a lot of the times I see those two things working together.
Yeah, so I know we focus mainly on lidar, but that's a big part of what we do as well. We collect really high detail aerial imagery, and it's a nice combination to do them both. So we often do them both independently, so we can use the imagery and the lidar as a check. We can use them to compare each other to make sure we're not having any issues, and then they kind of split off. So our imagery is used for all of our 2D portions of our engineering drawings. So that's basically anything you can see. We're picking it up and we're mapping it. And then our LiDAR is used for the 3D portion, which is the surface model. And then we bring them together at the end.
So oftentimes I see people focusing on one or the other, and I'm always curious to hear experts' opinion on this. Do you see them as being complementary or competitive, these two different technologies?
We've always kind of viewed them as complementary. I know that LiDAR is competitive with traditional stereo photogrammetry because the breakline generation and the 3D mapping is something that was traditionally done with the stereo. But we've kind of just switched over to doing everything 3D related with LiDAR because the benefit of being able to see under the vegetation and to generate so many points on the ground that don't have to be picked up manually has been a huge benefit for us. But then the imagery is just as crucial too. When we're doing break line generation, for example, we need the imagery in the background to be able to see what we're looking at. It makes everything a lot easier. So they really go hand in hand. I mean, it does happen, but it's fairly rare that we go to a project and we just collect one or the other. We're usually getting both nowadays.
I just want to clarify here. What are you actually talking about when you talk about break line generation?
So a break line is just you can think of it as a 3D polyline. At the start, I was talking a bit about how we have to thin our point clouds down because we're getting a lot of data. And let's focus on something like a curb, for example. In our LiDAR data, we are getting enough points to be able to really well, like define a curb really well. The unfortunate thing is we can't bring millions of points into let's say AutoCAD, for example. So what we have to do is we break it down into a thinned data set and then 3D polylines to represent features like curbs, retaining walls, bridges, that kind of thing.
Thank you very much for clarifying that. I should have asked you earlier in the conversation. So you talked a lot about working for clients there. So and you talked about like the market pressures, what the market wanted. When a client comes to you, do they already know what can be achieved with LiDAR? Or do they just know, oh, I can generate the surface? Great, that's it. I just need a surface. Or I guess the question is here, how much education is there around LiDAR as a product? Do people already know exactly what it can do? Or are you constantly needing to educate people and explain and go into depth? Or do they come to you and say, we know what we need some LiDAR, and because we know exactly these five products we can generate from it, and this can solve these seven problems for us.
We generally have three types of clients, I would say. So, especially our geospatial and utility clients, they know LiDAR, they know what they want already. They're like, hey, we want this data set collected and we want it done with UAVs because it needs to be this dense. And, we just go and do it. Probably one of the largest portions, all of our engineering clients, they maybe are familiar with the word, but we usually do, demos and presentations with them to kind of familiarize them with what the data set looks like and what our final deliverables look like, especially our land surveying clients, especially clients that are switching over from doing things, manually in the field with like a total station or RTK or a level. They really want to see what's going on. They don't just want to get a map from you with no idea how it was generated. So they definitely are interested, and we do a lot of education with them. And then we also have clients that don't care. They want a map. They want to see some contours on there. They don't care how it was done.
Yeah, and that's fair enough. That they're just interested in the sausage, not how it was made, and that's fine. You talked earlier about the last 10 years that this has really become more available, more accessible, maybe because the technology has changed and things have gotten cheaper, maybe because the platforms have changed, maybe it's just because more people understand what it can do and therefore more demand. So sometimes when we see a technology like this show up and become more available, it pushes another technology out. Is there a technology that LiDAR is sort of pushing out, like LiDAR from drones? Is it pushing out another technology?
No, I wouldn't say that. I did mention stereo photogrammetry. There's been some jobs that would have been traditionally done with that, as well as some, supplementation to get features that are under vegetation that are now being done with LiDAR. But there's a lot of work right now, and it's almost creating its own market space, I would say. Yes, we are taking a bit away from maybe the photogrammetry or maybe some work that was traditionally done with RTK, but those fields definitely still have lots to do, and there's not something that is being totally thrown out, I would say.
Again, sometimes when new technologies become more accessible, other people show up as well and start using them. And let's say I had $30,000 to go and buy the drone. I'm not a drone pilot, so it's not going to happen. But let's say I did, and I got some, flight planning software. Do you think I could go out and sort of create the same kind of data, the same kind of accuracy as what you can?
Yeah, I have total faith in you, Daniel. Go ahead. It's difficult. I will say it does take a while to learn what you're doing, how to interact with these data sets. It's difficult to create a good calibrated point cloud, but from there, it's even more difficult to turn that into useful information. Most of our clients don't want an enormous point cloud just handed to them. In fact, almost none of them do. They want to be able to make something out of it, which it takes a lot of experience to be able to do that. So I will say, if you're looking to get into it, make sure you make some key hires, people with experience.
The reason why I asked this question is because a lot of the times we hear about technology becoming available, and then people start throwing around this word democratization, right? We're lowering the barriers to entry. So I was just curious to what your take would be on this. If anyone can just go out and as long as you've got the money, then you can compete in the market. But it sounds like there's more to it than that.
Yeah, and it totally depends on what you're trying to accomplish too. I mean, LiDAR is being democratized in a way because it exists on iPhones now and iPads. So anybody can walk around and do a quick scan with their phone. But when you're trying to produce high accuracy survey grade deliverables, or especially work for utility companies, you better know what you're doing, because if you make mistakes and if you deliver something or overpromise, there could be real world consequences, especially when you're talking about power lines and in forest fire management.
Yeah, so let's stay with the idea of real world consequences for a second here. A couple of times on the podcast now, I've had guests that have referred to data as being a type of infrastructure. And so as soon as we use the word infrastructure, there's this almost expectation that somebody needs to be in charge, somebody needs to be on the hook, and somebody needs to make sure this thing is maintained. because we're going to build other products, other services on top of this. Do you see this when you think about some of these models that you're creating? Like, do they go out into the public? Are they maintained and updated?
Yeah, of course. A lot of the UAV data sets, I guess, would say are kind of limited to one or two uses. They're generally smaller jobs, but when you think about LiDAR on the whole, looking at the United States, for example, they have a national 3D elevation program where the goal is to get LiDAR for the whole country. They've done a study and they've identified over 600 business cases for it. So they really see the value there. And it kind of puts things into perspective when you're thinking about processing something that is going out into the public. It's going to be used for infrastructure or flood risk management, natural resource conservation, wildfires. I mentioned that, and forest management too. So, I don't know, a lot of large forestry companies or city governments, they have forest inventory programs, and the LiDAR can be used. So, when you think about all the potential uses, it really makes you, I guess, just be a little bit more careful about what you're putting out into the world.
Again, if we could just stay with this idea of infrastructure for a second here, when people create their data set, do you see them just sort of writing in the metadata, this is not being actively maintained, or this was collected by these people, and this is the level of accuracy? Or can you see some sort of structure around this where people are saying, if you're going to contribute once, there's an expectation that you will maintain it? Or do you think the government of the United States will maintain this data set?
Yeah, so their plan is to recollect at an interval. I don't remember what that is, maybe 7 or 10 years or something. But all the data sets that they have very accurate metadata for them. So the data it was collected, when it was published, the accuracy, the number of control points used. So there is a lot of metadata available for these publicly published data sets.
Just to try and round off the conversation here, if we come back to drones again for a second, you've said there's been a lot of advances in terms of technology in the last 10 years. What do you see for the next, 5, 10 years? And I realize it's difficult to look out into the future and make guesses, but if you had to guess, what would you expect to see in 10 years' time? Is it just a case of smaller, lighter, cheaper, or is there something else out there?
Yeah, smaller, lighter, cheaper is actually always my go-to. That's, I think, the way things are going. But I think topobathymetric is something that you could see driving drone innovation. There's a couple companies, I mentioned Regal, Astrolight, that have made these sensors, but we're not really seeing a widespread use of them, and specifically not by governments. So, governments are probably some of the biggest purchasers of shoreline information. So I think that'll be something that we'll see in the next 5, 10 years. We'll get some systems that are really performing well on UAVs that can get both topographic and also sub water surface data.
I know that you have a background in this. Would you mind just sort of giving us an understanding of what kind of depths we can collect at, what kind of water clarity we need, that kind of thing, so the listeners have a bit of an understanding of what this might look like, where it might be useful?
The application for that is the near shore. So it fills in the gap in between topographic, just ground LiDAR and sonar from vessels. Because for the sonar, it can be very difficult and time consuming for them to collect really close to the shore. So, it's more efficient to get anything from LiDAR. And the scanners range, you can get anywhere from like 10 centimeters all the way up to, I think, 30, 40 meters depending on the water clarity, maybe even deeper than that. And that's what it really comes down to. So with the topographic regular, aerial lidar, you watch for clouds, you watch the weather, and you're good to go. But for the topobathy, you also need to be watching out for the water clarity, specifically turbidity, and that can be anything from lowering, they call them Secchi discs, into the water, it's just a circular disc that you lower in, and you see how far down it goes, and that kind of gives you an idea how clear the water is, all the way to live turbidity monitoring buoy that's spitting out real time measurements to your cell phone. That can be done just to create really nice charts, and it has some of the same flood mapping, some of the same applications that I mentioned earlier.
I feel like I'm asking a lot of really silly questions today. And here's another one. One of the reasons you said that LiDAR had an advantage over photogrammetry was because you could see through vegetation. Is this the same thing when we think about doing a LiDAR bathymetric survey?
Yeah, yeah. So you can get down through eelgrass and seagrass and different types of aquatic vegetation as well. And I should probably clarify. I guess it's not exactly seeing through vegetation. The laser beam isn't passing through trees and leaves. It is getting multiple returns per pulse. So it is just because the light is passing through small, very, very tiny gaps in the vegetation to get down through to the ground, because you don't usually have just a totally blocked out, wall of vegetation. There's always tiny little gaps that the light can get through and return back up to the sensor.
Thank you very much for clarifying that for us. I mean, that was pretty clumsy of me to describe it in that way. Lucas, I really want to thank you. I found this conversation absolutely fascinating. I appreciate your time. And above all, I think I really appreciate your patience. Thank you very much. If someone's listening to this and they think, wow, I would like to connect with that guy, I would like to find out more about what he's working on, or perhaps ask some more questions, where can they go to do that?
Yeah, you can find me on LinkedIn. I'm fairly active there. I post a lot about the work that we're doing and, comment on other people's stuff too. So feel free to reach out to me that way. And I just wanted to say, thanks for having me on, Daniel. I'm a fan of the show, so it's a big honor to be on.
You are most welcome. I've really enjoyed talking with you. So I really hope you enjoyed that conversation between myself and Lucas Fraser. I will put a link to his LinkedIn profile in the show notes. You can catch up with him there. When I was listening back to this episode, I realized that I was using GPS or saying GPS instead of GNSS, and Lucas kept patiently correcting me on that. And I just want to say I do recognize that. I apologize for it, and I'll do better in the future. It also occurred to me when I was listening back to this episode that we didn't spend much time on describing what an IMU is. So an IMU is an inertial measurement unit. That's what IMU stands for. And what we need here is we need the combination of these two things. We need the GNSS to calculate the three degrees of freedom, so the longitude, the latitude, and the altitude, and we use the IMU to calculate the roll, the pitch, and the yaw of the sensor. So we're trying to figure out the pose of the sensor here. So we didn't spend much time in this particular episode going into details around that kind of thing, but if this is something that interests you and you want to know a little bit more about it, then you might be interested in an episode I published a wee while back called How to Augment Reality. This was with Tori Smith from Matbox Computer Vision and Augmented Reality platform, and he goes into a lot more depth around this in a way that everyone can understand. So that's worth checking out. So another podcast episode that you might find interesting was an episode around the Point Data Abstraction Library. If you go back in your feed and look for that, if you haven't listened to it already, it's really interesting. My guest was incredible, Howard Butler, absolutely brilliant guy, and talked a lot about collecting these point clouds, how he processes it, and mentioned some really, really interesting tools that are free and open source. And I think that if you're into point cloud data, you'll find that interesting. So that's well worth checking out. I'll put links to these things in the show notes. And it's also worth mentioning here that we publish quite long form articles about each episode on our website, mapscaping.com. So if you missed anything, you can go along there, and a couple of days after each episode goes live, it should be available to you there as well. So the way this podcast works, or the way I do things, is I look for a topic or I look for a guest. And let's say I find a guest. And my first step is to reach out to this person, organize a time to have what I call a pre-interview. And, we have this kind of casual chat. We get to know each other and we align on questions and topics. What would overlap with their area of expertise, and what would serve you the best. I spend quite a lot of time with people, I guess is what I'm getting at. And Lucas is a really nice person, super nice, generous guy, very knowledgeable, very patient. And so I'd just like to invite you again, if you are active on LinkedIn or use it, reach out to him. If you enjoyed the episode, let him know that. Connect with him there. If you have questions, I am confident that he will take the time to help. And that's it from me. That's it for another episode of the Mapscaping podcast. Thank you so much for tuning in again this week. It's much appreciated, and I really don't take it for granted. I really do appreciate it. And as always, you're more than welcome to reach out to me. And in fact, I would really appreciate it if you did. You can find me on LinkedIn. There'll be a link to my account in the show notes of this episode. You can also reach out to me on Twitter at Mapscaping. And of course, if email is your thing, feel free to send an email to info@mapscaping.com. Send me a thoughtful question and I will send you a thoughtful response. Thanks very much. I'll see you again next week. Bye.